isotope. Each element consists of one type of atom. For example, the magnesium element is composed of the magnesium atoms and the gold element is composed of gold atoms. But often in a natural environmental sample of an element, the constituent atoms don't have the same mass. These atoms that have different masses but belong to the same element are called isotopes. In the periodic table, we show each element with a symbol. For each atom, two characteristics can be determined, and these two characteristics are usually written on the upper and lower side of the element's symbol. And by means of them, the number of subatomic particles of an atom can be determined. In this symbol, Z represents the number of protons in an atom. Atoms are normally neutral, so Z can also indicate the number of electrons. A is a mass number that represents the total number of protons and neutrons. So, with a simple calculation as below, we can determine the number of neutrons in an atom. The isotopes of an element differ in terms of the number of neutrons, but they all have the same number of protons. Note that the chemical properties of an atom are determined by the number of protons. For this reason, the isotopes of an element all have the same chemical properties, but they differ in some physical properties related to the mass, such as density. The abundance percentage of isotopes of an element in nature is different. Some isotopes of an element may not be stable, which we call radioisotopes. The nucleus of these atoms is not stable and decays over time. These isotopes are radioactive, and as a result of effort, they release a large amount of energy in addition to energetic particles. Most nuclei in which the ratio of neutrons to protons is equal or greater than 1.5 are unstable and radioactive. Although radioisotopes are dangerous, with the advancement of science and technology, mankind has been able to control them and use them in fields of medicine, agriculture, and etc. Among carbon isotopes, carbon-14 has radioactivity and is used to estimate the age of old objects and antiques. Uranium is the most well-known element. One of its radioisotopes is often used as fuel in atomic reactors. This radioisotope is U-235, whose abundance in a natural sample of uranium is less than 0.7%. To use it, the natural sample of uranium is enriched in such a way that the percentage of this radioisotope in it increases. Iron-59 is a radioisotope and is used in imaging the circulatory system because irons are present in the structure of hemoglobin. After a certain period of time, the mass of radioisotopes decreases, and during this time, some of their mass is converted into energy and energetic particles. The time it takes for a given mass of radioisotope to be halved is called half-life. If the half-life of a radioisotope is 1 hour and we have 20 grams of it, within 1 hour 10 grams of it will be converted into energy and energetic particles.